Welcome to The Climate Fix. My name is Asim. On this show, we shine a spotlight on non-profits, academics, corporations, startups, anyone working on a solution to the climate problem. On today's episode, I'm speaking to Jean-Marc Jefferson from N2S. Jean-Marc has over 30 years experience leading business units, sales and marketing teams, and service operations at IBM, Dimension Data, Orange Business Services, and Accenture. He's passionate about sustainable IT and currently works as the business advisor for N2S. I met Jean-Marc at a small sustainability conference for local government departments in the UK and held at the Microsoft Reactor in London. It was organised by an organisation called the UK Authority and another Microsoftie called Ellen Wilson. He gave a talk about something N2S are working on called bio-leaching. It's used in something called urban mining, a method of recycling printed circuit boards. And yes, it's as interesting as it sounds. I made sure to have a conversation with him afterwards, and I knew right then and there that I wanted him on the show, and I'm really glad he agreed. So let's dive straight in. So hi, Jean. What's the climate problem that you're solving?
Asim, thanks for inviting me on this podcast. Essentially, what we're looking to do here is to take care of unwanted IT assets on the return journey from the client base. So essentially, what we're trying to do is look at how we can best deal with unwanted hardware IT assets that come out of client environments. So that's anything from the reuse of that IT through other customers or even internally sometimes. It can be recycling, and it's absolutely 0% to landfill. So everything that we do is looking at maximizing the life of unwanted IT assets and thereby reduce the carbon footprint and support the planet from a sustainable perspective. That's essentially what we're trying to do. So reuse first, recycle second, 0% to landfill. That's our mantra.
Why is that a climate problem that's worth solving?
The way that we currently essentially measure the impact that we have on the planet is through what we call embodied carbon dioxide. So CO2e is the measurement that we most commonly use in terms of the negative impact that we have on the planet. There are a number of others as well related to CO2e. One of them is fossil fuels, and the other one is H2O. But if we can manage essentially through proper, meaningful metrics, the impact that we have from an IT perspective throughout the production of the IT. And if we keep the IT in use longer, then that CO2e footprint extends over a longer period of time. It kind of obviates the requirement to create new IT within shorter timescales. Of course, there'll always be clients that want the latest, the newest technology with the biggest processing power, the biggest memory, and biggest communications, but that's not always a requirement for everybody. I mean, for example, I'm sitting here with an Asus laptop that's 6 years old, perfectly good for me in terms of running anything that I need to run, from an Excel spreadsheet to PowerPoint presentation, even this podcast, for example. So if we can measure these, the impact that we're having by extending the life of technology, and also by the recycling that we do, as opposed to going and finding things from new. So new gold, for example, costs an awful lot more to mine out of the earth than if you use urban mining, for example, to mine it through PCBs in laptops. So fundamentally, what we're doing is we're saying there is a hierarchy of things that you can do with unwanted IT assets. Reuse is far better than recycle, but recycle is better than landfill. And if we can then measure that in terms of water, carbon, and in terms of fossil fuels, and then if we can measure that also against the United Nations Sustainable Development Goals. I mean, for example, the goals that we measure are number 6, which is clean water and sanitization, number 12, which is responsible consumption and production, and number 13, which is climate action. So all three of those, we measure our impact from an environmental impact perspective, and we demonstrate that for our own purposes, for our clients, and to the government.
And so just to summarize, what you're doing or what you're trying to do is to reduce the impact of the embodied carbon. Just to give a definition for the listeners, and I'll correct me if I'm wrong, this is the carbon that was released in the creation of things such as hardware or devices. And sometimes we look at the carbon that's released during the lifetime of a device by its use. But actually, there's a large amount of carbon was released when the device was actually created. So it's really important to make sure that it's used effectively and to also make sure that its lifetime is increased. And that's why you're talking about reuse. And then the other alternative is recycle, which I sounds like when you rip it apart and you reuse the different parts of it. And that's kind of what your goal is, it sounds like.
Yeah, so you've touched on a couple of very, very important points that are worth unpacking actually at this point. The first one is that we generally have a system in place already in terms of measuring energy through the life cycle of technology. And you see that pretty much on the European Union stickers that we see on the side of fridges and on the side of other white goods today. We don't do it in exactly the same way for IT, but we do measure consumption of things like kilowatt hours of electricity for IT throughout the actual operational use of their life. But when you think that anything between about 60 up to about 80% of the embodied carbon footprint of technology is through the manufacturing process, from sourcing the raw materials through transportation, through the manufacturing assembly, and thereafter the logistics to get them to market. That's not something that we measure today, and yet we should and we could. And by measuring these things, we can then look at how we can minimize our negative impact on the planet and maximize the positive impact through reduction of carbon footprint, reduction of water consumption, and the reduction of fossil fuels that go into the manufacturing process. Because what we're doing is we're keeping our laptops on our tables for far longer. We're keeping the server capacity in our data centers going for longer, or if we can't, we're then at least allowing somebody else to benefit from them rather than them having to purchase from you. So there's a whole bunch of stuff there that's really important that you've just flagged up. But really, what I think I'd like to focus on a little bit more at this point is that if we look at the recycling part of the value chain, we're not going to avoid recycling. Recycling is going to happen because everything comes to the end of its natural life, and it's what we do at that point that's really really critical. Now, traditionally, and we're a firm that actually does recycle. We've got a WE license that enables us to dispose of IT technology ethically and in the best fashion possible with zero to landfill, as I said. The traditionally what's happened is that there are certain parts when we do the disassembly of IT, when we do this manually, what we then do is we put it into piles of, say, steel or copper or mixed metals or plastic, or and we extract the batteries because they're hazardous waste. Now, we do all of that internally, and we then pass on the broken down parts or the broken down bundles, if you like, to downstream recyclers. So the copper will go to somebody that smelts it and then puts it back into copper that's A grade copper that can then go back into the making of cables or even PCBs, printed circuit boards, that is, or whatever it might be. But one of the things that we kind of lose control of is with printed circuit boards, and that is that printed circuit boards need to be dealt with in a specific fashion because they've also got hazardous waste. That well, they should be treated as hazardous waste. They're not always treated that way, simply because of the way they're constructed and the component parts. So what we tend to do there is, in the past, we've tended to take those PCBs and have a specialist recycler come and collect them, or we send them to the specialist recycler that then does a little bit more processing before eventually what happens is one of two processes. They're either thermally deconstructed to get access to the rare and precious metals, rare earth and precious metals.
Firmly deconstructed sounds like you just burn them.
Yeah, exactly right. It's essentially it's incineration. Clearly, that's not going to be brilliant for the planet either, right?
Yeah, yeah.
The other method is what they call non-thermal, but essentially what that is it's chemicals in solution, and so there's acids, there's mercury, And a lot of this obviously also gets done in places in Africa, for example, which are not the best conditions to do it under. The mercury goes into the soil, which goes into the water table. The crops, the chickens, the eggs, all end up with mercury in them that then go back into the food chain. Children are brought up with mercury in the, and on it goes. So, one of the things that we've been looking at. And is now in flow is how we can better process printed circuit boards. And there's a number of reasons why we'd want to do that. But essentially, we've come up with a methodology which was originally discovered in South Africa, maybe 40, 50 years ago, but it's never been productized, if you like, which is bio-leaching. And so bio-leaching enables us to do with printed circuit boards what we really need to do in a way that's better for the environment. It's better for workers. It's actually better for the printed circuit boards as well, because with increased miniaturization, for example, we're able to have bacteria break down the boards or the glue that glues the metal to the boards, and thereby extract the best possible return on the rare and precious metals. I mean, if we think about a mobile phone, for example, they're incredibly miniaturized, huge amount of functionality, and a huge amount of rare and precious metals. I mean, copper's the biggest metal in there, but following copper, you've got things like palladium and platinum and indeed gold. And there's a couple of to my mind, there's a couple of interesting statistics here, and one of them is, and you've probably heard various versions of this, but the saying goes, there's 100 times more gold in a ton of mobile phones than there is in a ton of gold ore.
I'd never heard that before.
Yeah,
That's fascinating.
it's fascinating, but is it true? It's
Mm.
probably not true. It could be up to 100%, up to 100 times, but it's
Mm.
probably between 30 and 100 times.
That's still very impressive.
It's
That's
it,
yeah.
it's still very impressive, and what it means is that there is value in using bioleaching to do urban mining, because we can extract that gold, however small it is, via the bacteria in solution, and get it repurposed and reused. And so that I think is quite interesting. But one of the things that isn't as often referred to is what we talk about in terms of new and secondary embodiments for metals. So, new embodied carbon, for example, of gold is just short of 18,000 kilos to extract 1 kilo of gold.
And so, why do we call this new embodied carbon?
Because essentially, that's when we're looking at extracting gold from gold ore
Ah,
straight out of the ground. So that's why it's called new. Whereas when we're looking at secondary, we're looking at extracting gold from the printed circuit boards on the IT. And the cost of doing that is 397 kilos of carbon rather than 17.9 thousand. So, so essentially, the CO2 saving by extracting gold from a PCB as opposed to out of the ground, for every kilo of gold, it'll be 17,500 kilos of carbon
wow.
saved. So there's a commercial reason why we want to extract these metals from PCBs, and there is an environmental reason why we want to do it, apart from the incineration or the use of chemicals. And that is really why we are so focused on this part when it comes to recycling of unwanted IT assets.
Oh, that makes a lot of sense. So, it will take a lot less carbon to extract the gold from devices than to extract the gold from ore, which is, I think, something I see quite often when solutions are presented in the sustainability space. When they're then investigated a little bit deeper, you sometimes discover that unfortunately it causes more damage because it wasn't all the external factors weren't considered. And it sounds like you've really factored that in, and in fact, this actually forms your primary basis for this idea.
Yeah, it's interesting. I mean, I wouldn't say it's 100% sustainable in the sense that you've still got a printed circuit board material on the back which still ends up as waste, but there's nothing we can do about that at the moment. I mean, I understand that there are companies that are looking at producing edible printed circuit boards to go into their new technology. Now, once we get to that point, we really have got a circular economy,
I think you mean edible by not by humans, by microbes. Yeah,
by
yeah.
microbes.
My
Yeah,
son would have a field day if I had edible circuit boards in my phone.
I know. Can you imagine? Yeah.
So yes, bio-leaching has or is a less carbon intensive way of mining gold, but at the same time you are actually extracting gold and other precious metals from these devices. So it's a commercial opportunity. It seems like a win-win. You earn money from mining gold, and also it's a less carbon intensive method. How do you see this scaling out? Like, how do you get from where you are right now to the maximum impact that a solution like this could have?
Yeah, that's a really good question because it's great to have a great idea, but can you actually take it to all the way through to production? We started on a three-phased approach, which is proof of concept, which we've just completed. Now, the proof of concept is a phase that we have. Now, here's another interesting thing in terms of circularity. The proof of concept around bio-leaching is a joint venture between N2S, commercial firm, the University of Coventry, academia, and Innovate UK to provide some funding, government. So this is a fantastic example of how, if you get the three elements in balance between academia, commerce, and the government, you can actually turn out viable solutions that are sustainable and that are going to help our planet moving forward. That's why we're also part of DESA initiative, just as Microsoft are. Um, the thing about it is that we have done the proof of concept, so we have established in a laboratory environment that we can extract copper and we can extract gold. The methods through bioleaching, so using bacteria to break down either the glue that's backing those metals onto the printed circuit boards, or indeed the metals themselves. So some bacteria eat the metals, other bacteria eat the glue. That's it. That's pretty much simply how it works. But of course, different bacteria work in different ways on different metals. So we've come out of proof of concept now because we can copper in the laboratory, and we can do it to a level that is commercially viable. So we've now gone into pilot phase with a couple of test clients where they're providing us with certain circuit boards, and we're analyzing them and looking at how best to extract not just copper and gold, but also how we can deal with some of the other rare and precious metals. And it's showing up some very interesting feedback at this point in time, which is that some manufacturers actually have far better quality PCBs than others. Um, and I don't think I'd be telling tales out of school if I was to say that typically your more expensive manufacturers in terms of technology and the better known brands are usually using better quality components and
Oh.
better quality base metals and precious metals, or greater quantities of these.
Mhm.
And of course, it's typically these are the same firms that when you end up reselling and so going through the resale cycles for their technology, they're the ones that typically have a better residual value too. So there's some quite interesting correlations here. But yes, as we're going through pilot, we are further testing what it's going to take to perfect the recipe, the cooking pot, and indeed the ingredients that enable us to extract more value out of the printed circuit boards. So we're doing that, and we anticipate that that's going to happen now. Well, with coronavirus, I'm afraid it's going to take a
Yeah.
little bit of a delay, but we still plan on being able to complete that within the next 18 months. At which point in time we will be ready to go into full production. Um, my my dream, if you like, is that we can essentially provide at cost for non-commercial organizations the IP that we have created in the form of a cooking pot, some ingredients, and a recipe, so that essentially we can promulgate bio-leaching throughout the world. Because clearly it wouldn't make any sense if we were looking at recovering PCBs from everywhere around the world back into the UK so that we could process them. Not that we could do it anyway, with the sheer volume of PCBs coming back, but actually from an environmental perspective, it wouldn't make any sense either. So the idea would be to look at it more as a social venture, working perhaps with the UK government and also perhaps the United Nations to be able to allow a greater audience to access the technology that we are, in essence, creating here around how we extract these metals from unwanted IT technology. And that really, to me, would be the essence of a sustainable urban mining solution for the world.
And I love the sound of that. And I also love the title, by the way, Urban Mining. I think it's fantastic. So, your idea and your dream is to be able to provide people with kits where they could do urban mining in their own area, and they're mining precious metals. So it's money. They would buy one of these kits and they could have essentially a business, it sounds like. A cottage industry, if you say, of bio-leaching throughout the world. That's how you see it?
Absolutely. In fact, I call that biorefinery in a box.
Mm.
Literally out of the box, you can set up your business, you can start breaking this stuff down, and you can start generating income at a at a local level. And really, I mean, it could be a cottage industry, but it could also equally apply to any recycling center, for example.
Hmm. Yes, of course, yeah. But also, because earlier on in the conversation, you were talking about how, and I think you were saying in South Africa and in places where the existing recycling process is perhaps using non-thermal or acid techniques, it's actually quite bad for the environment as well. And it sounded to me that that was happening in almost a more localized fashion than a industrial fashion. Or
Yes, indeed. I mean, there are places that are particularly that are hotspots in terms of how not to extract goodness from unwanted IT assets, and Ghana is one of them. Nigeria is another one of
mm,
them, and that's on stuff that's essentially been discarded. A lot of it in the West. So whilst it should have gone through a process that would ensure it wouldn't go to landfill or be exported. Unfortunately, still a huge percentage of unwanted IT does end up in landfill in places in Africa predominantly, but also Asia. And then, of course, local people can see that there's some level of goodness in terms of trying to extract the copper and other metals from these discarded IT assets from the first world. And unfortunately, the way that they then go on and extract it in the only way that they know how is extremely nocive for their health, and the health of their children and for generations to come. So anything we can do to somehow reduce that kind of activity through things like bioleaching is going to be is going to have another benefit to the planet, and that's where we look at benefits outside of embodied carbon and more towards the full eco costs of what we're doing. And if we can actually have a positive impact on that, then I think we're in a much better place, both here in the UK, but also when we look at communities that are perhaps not as fortunate as we are.
mm, yeah, love that. Fantastic. I am now imagining a large mountain of discarded mobile phones somewhere in the world. What is the market size of this? How much gold and precious metals? Do you have an idea about that?
I again, I'll use a statistic, but simply because I've seen it in a number of places, including the World Economic Forum documentation. But apparently, something like 8% of the world's gold is currently sitting in mobile phones that are either sit in people's drawers or literally have been committed to landfill. So we're talking about a fair amount of metal, and actually, when we look at it in terms of the full eco costs of what we're doing from an IT perspective, I say we, it's the royal we.
Mm,
Um, the 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 problem that we're going to face at some point is that there will be a scarcity of rare and precious metals coming out of the ground. So not only is it bad to rely on pulling all of this stuff out of the ground because it has a massive carbon footprint impact, whereas urban mining could help us, offset that. Um, we're going to end up at a point where there simply isn't the required amount of metal to keep feeding our ever increasing requirement for IT and communications. And a good example of that is the Democratic Republic of Congo, where something like 60, 70% of the world's cobalt is mined. And
Oh.
cobalt is clearly going to be massively important, especially if we're looking at creating long life batteries for electric vehicles, for example. Um, and yet this cobalt is mined in what is not a free country. It's quite often mined again in a fashion that's not good for the workers. So health and safety has gone out the window, and quite often it's done by underage, well, by children.
Mhm.
And so there's a whole bunch of elements there that are really not that we should care about when we're looking at what we do with our existing IT and how we process it when we no longer require it. So anything we can do in terms of recovery through urban mining is going to be fantastic. By the way, it's not a panacea either, but
Mm.
it's going to help greatly in terms of offsetting some of the risks and some of the malpractice and um, some of the iniquities that are occurring right now today under our noses in other parts of the world. Um, I mean,
Mm.
actually, at the end of the day, we could even end up in a situation where if China, for example, has control of 60 to 70% of all of the metals that are coming out of the earth that are required for electronic devices, if they give us, if we are denied access to those metals because somehow we fall out with them, maybe over coronavirus, I don't know. But
Mhm.
if we fall out with them and all of a sudden there is a shortage of cobalt or of lithium or of palladium or any of the other things that we require, we'll soon find that we're going back to two tin cans and a piece of string if we're not careful.
Mhm. That's a really interesting point you mentioned there. And as you were saying it, it reminded me of how the oil shocks from the 1980s triggered energy independence or movements for energy independence in various countries because they realized they were too dependent upon oil from other regions. Then that itself triggered an investment in renewables.
It did, and it also triggered a way of looking at how you could extract mineral wealth from via other means, i.e.,
Mm.
what the US have done in terms of fracking.
Mm, yeah.
Because once the US managed to get themselves less dependent on Middle Eastern oil, the geopolitical considerations for being in that region is somewhat reduced, not eliminated, but somewhat reduced.
Yeah, yeah, and the same thing I was also thinking about coronavirus because for the listeners, we are in the right in the midst of coronavirus right now, and I'm reading a lot about how supply chains for essential goods are disrupted and how our globalized economy right now, where we just expect things to arrive from different countries, people are realizing that has a problem when your country needs something that another country isn't willing to give you. And it sounds like urban mining might even be a way around that, or one of the things a government might even want to institute to ensure they have some sort of independence from other countries.
Yeah, indeed. It's a way of looking, I think, in a different way at what we do with our waste electronics and how that can benefit economies locally. I mean, as I said, earlier in the conversation, one of the things um, that was worrying us at N2S was that we had no. Once we gave our printed circuit boards to a third party firm to then do something with them before they eventually end up in the incinerator, you kind of lose track of where this stuff's going. And we don't like that. We like to know exactly where it's going. So by bringing it closer to home, again, you're helping the planet because you're not having to ship it halfway around the world. And plus, we know that we do things, or the firms that we're talking to are doing things in a way that is ethical and complies to local and maybe even European regulations as well. Although I'm hoping that those two won't diverge too much moving forward.
Yeah,
Yeah.
hopefully. So moving on, I had a look at your background, and you've got a long, diverse background in a variety of different industries and a variety of different sectors. What inspired you to move into this space?
That's a great question, Asim. Um, so I spent 30 years essentially on what I call the outbound journey, which is how to get technology and associated services out to companies that required them. So I worked, yeah, I worked in a number of systems and as systems integrators and infrastructure integrators to provide mostly telecommunications to Fortune 500 type firms, FTSE 100s, and it struck me one day when I was sitting in my office at Accenture, where I was responsible for resale of technology and logistics services. It struck me that there was an awful lot that wasn't being done on the return journey for unwanted IT assets. And at that point in time, I struck up a friendship uh, with a chap who I now work with at N2S called Andrew Gomersall, former England rugby player, World
Mm,
Cup winner,
wow.
and 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 we were sort of fussing around with another friend of ours who currently works at Boots called Simon Ellis, and we were fussing around looking at how we could create a sustainable model for the return of unwanted IT assets. And we talked about it, and we tried to put something together at that point in time, and it wasn't getting the market traction that we were anticipated. So I guess we were a little bit ahead of our time. But then 5 years on from that, I then reopened the conversation with both of those gentlemen, and I'm pleased to say that I now work with Andrew at N2S, and we're taking this initiative forward under our own steam.
Hmm.
And I think that we're finding an awful lot of traction right now.
Sounds amazing, and I'm really glad that you found the right time to start this.
Right time, the right place, and time to put something back.
Yeah, yeah, exactly. So one of the things I always like to ask is that it's quite hard. I find it's quite hard to be in this space sometimes. We're dealing with quite serious problems,
Yeah.
um, and at times we can be beset with people on both sides, perhaps, who maybe are not supportive as we need them to be. What are some of the things that keep you motivated every day to carry on?
Yeah, it's. I guess it's the grain of sand principle, um, and uh, and that is that every day, every one of us can make a little bit of a difference. And even if you just move one grain of sand every day from where it is to where it could be, you're going to find that your pile has moved. Um, it's funny. I was reflecting on this just the other day. I I'm a diver. I'm a keen scuba diver, so I'm quite involved in environmental impact anyway, because I see it underwater every time I
Mm,
dive. And the funny thing is that I don't know how many divers there are around the world, but let's assume it's a couple of 100,000 people that go out there on a regular basis. Every time, certainly every time any diver that I've ever dived with goes underwater, if they see any rubbish, they pick it up. And
mm,
so it might be a packet of crisps, it might be an empty bottle of beer. It could be some fishing lines, some monofilament. But if we just pick it up every time we see it, at the end of the day, the sea is going to be a better place for it. So I think every single individual on this planet can make a difference, and together we make a hell of a difference.
yeah, I completely agree with that. There's a saying that I believe has been attributed to Bill Gates, my benevolent leader, which is, let me remember it correctly. People overestimate what they can do in a year and underestimate what they can do in a decade. And I think what you're saying, it kind of speaks to that. If you just do a little bit every single day, you can achieve a lot throughout your lifetime. Yeah, so that definitely aligns with me.
Indeed, indeed, and you can't look at it as a massive problem that's insurmountable. You've got to sort of, and I'm not going to use the cliche that's often used here,
Mm.
but you've got to look at how you can make a little dent in that big problem every day. And you're right, over a period of decades, that problem's sort of halved, or maybe even it disappeared in some cases.
Yeah, yeah, true. So just a last question. Is there anything inspirational, something you've read recently, a person our listeners should follow, a thought perhaps you just have that you'd just like to leave everybody with?
Yeah, it kind of goes back to the diving piece for me. In 2013, I was part of a group of I think it was about 250 divers that assembled on the shores of Lake Windermere, under the guidance of a guy called Paul Rose, who's an explorer and TV presenter. You may have seen him.
Mm.
So Paul put out a call to action for divers to assemble um, at Lake Windermere in Cumbria, UK, national park, and we spent a day litter picking underwater, and
Mm.
200 divers turned into 10 tons of waste that went into a single shipping container, which was then repurposed for sculpture.
Wow.
Um, and if you go back to what I was saying about 200,000 divers globally, that's 8,000 tons right there for a single visit to go and clear out your local um, your local underwater space. Now, if you did that every weekend, or maybe every other weekend, it's starting to really, really make a difference. And that's where I'd love to get to with the return of unwanted IT waste. Let's take the Paul Rose principle. Let's get the call to action. Let's get people looking at how we can do more, keep things longer, and then when we finish with them, let's see if we can find them a second home. And if we can't, then let's put them through bio-leaching. That so Paul Rose is my inspiration.
Mhm.
It's not very glamorous to go and litter pick underwater, but at the end of it, you can make a hell of an impact, and that's fantastic.
That is amazing. You've given me shivers up my spine with that one. I really think that's a great piece of inspiration. Well, thank you so much, Jean-Marc, for being on the podcast. This has been a really interesting conversation, and I really appreciate you spending your time here.
Awesome. It's my pleasure entirely. Thank you very much, mate.
You've been listening to Asim Hussain on The Climate Fix. If you like what you heard, please hit subscribe on your favourite podcast application. It really does help. Information about this episode, including all the links that we mentioned, can be found on our website, theclimatefix.com. If you want to message me, you can find me on Twitter as JawAche, or you can email me at hello@theclimatefix.com. If you want each new episode neatly packaged together with the show notes and sent to your inbox weekly, then subscribe to our newsletter, which you can again find on theclimatefix.com. Till next time.